What is a distributed control system, DCS? A distributed control system is an automated control system used in process industries where control functions are distributed throughout the plant rather than centralized. It integrates process control, data acquisition, and supervisory control in a hierarchical manner. Each DCS node, controllers, operator stations, engineering stations, etc., communicates over a high-speed network, providing reliability, scalability, and redundancy. How is DCS different from PLC? DCS, suited for continuous process industries, oil and gas, chemical, power plants. Offers integrated control, batch handling, advanced process control, historian, and alarm management. PLC, suited for discrete/batch processes, packaging, machinery, automotive. Offers faster scan cycles, rugged design, simple logic control. Key difference: PLCs are logic-oriented while DCS is process-oriented. What are the main components of a DCS? Engineering station, configuration and diagnostics. Operator station, monitoring and control. Controllers/process stations, real-time control execution. I/O modules, interface with field devices. Communication network, redundant Ethernet/fiber. Historian server, long-term storage of process data. What is the role of an engineering station in DCS? The engineering station, ES, is used for configuration, database management, graphics development, control logic programming, system diagnostics, and downloading logic to controllers. It is usually restricted for engineering and maintenance personnel, not for operators. Explain the function of Operator Workstation, OWS. The Operator Workstation, OWS, or HMI provides a graphical interface for plant operators. It displays process values, trends, alarms, and allows manual control actions, start/stop, setpoint change. It plays a critical role in safe and efficient plant operation. What is redundancy in DCS? Redundancy ensures continuous operation even if one component fails. Common redundancy includes controller redundancy, dual processors. Power supply redundancy. Network redundancy, dual Ethernet rings. I/O redundancy, hot standby modules. This minimizes downtime and improves system availability, up to 99.99%. What are the types of I/O modules in DCS? Analog input, AI, reads 4 to 20 mA, 0 to 10 V, RTD, TC signals. Analog output, AO, controls actuators, control valves. Digital input, DI, reads on/off signals from switches, contacts. Digital output, DO, drives solenoids, relays, lamps. Special I/O, pulse counters, HART, Profibus, Foundation Field Bus. What is scan cycle in DCS? The scan cycle is the time taken by a controller to read inputs, execute control logic, and update outputs. Typical scan times are 100 to 500 milliseconds in DCS, slower than PLC because of complex process control functions. What is the role of a historian in DCS? A historian stores and retrieves large amounts of process data for long-term analysis, performance monitoring, reporting, and regulatory compliance. It supports trending, root cause analysis, optimization, and predictive maintenance. What is the difference between hardwired control and DCS control? Hardwired control, direct relay/analog panel wiring, difficult to modify, poor scalability. DCS control, software configured, flexible, scalable, centralized monitoring, reduced wiring, easier integration. Explain the difference between open loop and closed loop control in DCS. Open loop, operator sets output without feedback. Closed loop, controller automatically adjusts output based on process variable feedback, example, PID control. DCS mainly uses closed loop control for process stability. What is a PID loop in DCS? A PID loop, proportional integral derivative, is the most common control algorithm in DCS. P corrects proportionally to error. I. Eliminates steady-state error. D. Predicts error trend for faster response. Operators can tune PID loops via gain, reset, and rate settings. What are the communication protocols used in DCS? Proprietary protocols: Honeywell LCN, Yokogawa VNet. Standard protocols: Ethernet/IP, Modbus TCP/IP, Profibus, Foundation Field Bus, HART, OPCUA. Protocols ensure interoperability between controllers, I/OS, and field devices. What is the importance of time synchronization in DCS? All DCS components must be synchronized for correct event logging, sequence of events, SOE, and historian accuracy. Methods include GPS, NTP, Network Time Protocol, or master clock servers. What is an alarm management system in DCS? Alarm management ensures operators are alerted to abnormal conditions. Functions include prioritization, critical, major, minor, filtering and suppression, alarm shelving and acknowledgement, alarm rationalization to avoid alarm flooding. What is a control strategy in DCS? A control strategy is the arrangement of control loops, logic, and interlocks implemented in the DCS to achieve process objectives such as maintaining pressure, temperature, level, and flow at desired set points. What are soft points in DCS? Soft points are calculated or virtual points, not physical I/OS. Example: flow totalization, average of multiple sensors, or logic-based outputs. What is a sequence control in DCS? Sequence control is used for batch operations or stepwise startup/shutdown. The DCS executes predefined steps in a logical sequence, e.g., pump start, valve open, heater start. What is a faceplate in DCS HMI? A faceplate is a predefined graphic template for an instrument loop, pump, valve, transmitter. It shows process values, set points, mode, auto/manual, and allows operator interaction. What is the difference between manual, auto, and cascade modes in DCS? Manual, operator sets output directly. Auto, controller maintains set point using PID. Cascade, one controller's output becomes another controller's set point, used in advanced control strategies. What is SOE, sequence of events, in DCS? SOE records events with millisecond accuracy for troubleshooting and root cause analysis. It helps identify the exact sequence of failures in trips, shutdowns, or upsets. What are interlocks in DCS? Interlocks are logic conditions that ensure equipment safety by preventing unsafe operations, e.g., preventing pump start unless suction valve is open. They can be permissive, allow operation if safe, or protective, trip on unsafe condition. What is the difference between DCS and SCADA? DCS, plant-level control, closed loop, used in process industries. SCADA, supervisory monitoring across wide geographical areas, pipelines, power grids, often with remote PLC/RTUs. DCS is more control-focused, SCADA is monitoring-focused. What is load shedding in DCS? Load shedding is the automatic shutdown of non-critical equipment when demand exceeds supply, preventing total plant blackout. Common in power plants and refineries. What is Advanced Process Control, APC, in DCS? APC uses multivariable control, model predictive control, MPC, and optimization techniques on top of basic PID loops to maximize efficiency, reduce variability, and save energy. How is security implemented in DCS? User access levels and authentication. Firewalls and segmentation between control and corporate networks. Antivirus and patch management. Compliance with cybersecurity standards, ISA/IEC 62443, NIST. What is a controller scan time, and why is it important? Controller scan time is the execution interval for reading inputs, processing logic, and updating outputs. Shorter scan times mean faster response but higher CPU load. Must be optimized for process dynamics. What is hot swappable I/O in DCS? Hot swappable I/OS can be replaced without shutting down the system or interrupting operations. This improves maintainability and availability. What is OPC in DCS? OPC, OLE for process control, is a standard interface for interoperability between DCS, PLCs, HMIs, and third-party systems. Latest versions use OPC UA, unified architecture, with platform independence and security. What are typical applications of DCS in industries? Oil and gas, refinery units, offshore platforms. Power plants, boiler, turbine, balance of plant control. Chemicals/petrochemical, reactors, distillation columns. Pharma and food, batch operations, quality control. Water/wastewater, treatment plants.